Hi everyone, today I am going to teach a topic called carrier transport. Carrier transport. So what is carrier? As we know, in semiconductor there are two types of carriers. One is electron, other is hole. Both has the same charge, means the magnitude of charge is same for both electron and proton, hole. But they have the different polarity. Electron has the negative polarity, whereas hole has the positive polarity. What is the meaning of transport? The transport is nothing but it is the process by which electron and hole move in semiconductor. The process by which electron and holes move in the semiconductor is called what? Transport. So whenever electron and hole moves, that means charge is moving, and movement of charge is called current. So this movement, how it takes place in the semiconductor. So we will study one by one. Number one, the type of transport is drift transport. So drift transport. Transport means it is the movement of charge. So when we apply the electric field to the semiconductor, electrons and holes experience certain force, Coulombic force. Due to which the electron and holes start moving. So there is the acceleration and consequently there is the velocity. So the current due to this moment, due to this drift transportation, is called drift current. So let us discuss about this drift current density. Drift current density. Let us call it as JD. D for drift. Okay. So current density unit is what for a current density? So JD unit is nothing but ampere per centimeter square. Right? So this drift current also, there are two types. One due to the hole, other will be due to the electron. So when the whole moment takes place, so we can write JDP, let it be, JDP is equal to the charge density, that is nothing but charge of a hole into hole concentration. Hole concentration, I will denote it by P. Okay, hole concentration is denoted by P. So this is the charge density into Vd. Now let us see whether this expression is satisfying this unit. Check it. So EP, E is the charge, that is Coulomb, and P is the per centimeter cube, into Vd is nothing but centimeter by second. So which will be Coulomb second 1 by centimeter square, and coulomb per second is nothing but amps per centimeter square, which is same as this JD, right? So yes, our expression is correct. So J dP, that is the drift current due to the hole's moment, is nothing but this. Now this VD, velocity of the hole, is proportional to the electric field. E is the electric field applied, proportional to the electric field. So if more is the electric field, more force it will be experiencing, and hence velocity will be more, right? So now VD, if I remove this proportionality constant, means sign, then we will be getting a proportionality constant that is called mu P, that is the mobility of hole into E. So mu P is the hole mobility, that is the mobility of hole, or hole mobility, whatever you want, you can say the hole mobility, right? And unit, if you notice here, this is velocity by E, velocity by E. So unit will be, velocity is nothing but centimeter per second by E, means the unit of electric field is what? Is nothing but volt per second, volt per centimeter, so centimeter by volt. So this gives me centimeter square volt second, right? So mobility of hole is this. So now if I substitute this VD, that is the drift velocity expression, in this JPT, that is the drift current density due to hole, is nothing but E into P. VD is nothing but mu P into E, right? So let us call it as equation number 1. Again, this was due to the hole. Now similarly we will have the drift current density due to the electron. So for that the expression will be J ND is nothing but electron charge is nothing but minus of E times the concentration of electron, that is the N, into the velocity, drift velocity VD, and let us call it as VD dash, V dash D. Okay, because here we have to represent it, because both the velocity will be different for the hole and electron. It won't be the same velocity. It will be different. That we will be discussing while discussing this mobility. In that class, I will discuss about this V dash D also. How this V dash D and VD are different. Okay. So VD dash is nothing but same as this. It will be mu N into E. Here also it depends upon the. It will be negative actually. Why? Because this electron, the motion of the electron will be opposite to that of the direction of electric field, right? Because it will be coming towards the positive charge, towards the positive direction. So the electric field is from positive to negative, and the electron will be attracted by the positive side, so it will be on the opposite direction. So this is the V dash D. So J and D is nothing but minus of E N into minus of mu N E, which will be, this is E N mu N to E. So this is the current density due to electrons, right? Now, so the net, let me write here. Yeah, that's possible. We can write here. So net current density J D, the drift current density, is nothing but Jn plus of Jp. Now, if I add both these two, I'll have common factors E, small e, that is the electronic charge, and E is the electric field. These two will be coming out as a common factor. So we will be getting n mu n plus of p mu p times E. So GT. This is our grid current density, right? So hope you understood it. If you have any doubt, you can very well write in my comment box. And if you like this my class, please you subscribe my channel, and you can very well leave your comments on my channel. Thank you.